So I'm going to get into lots of detail here about how the projection system I've built for OOTP works and how to get it set up step by step if you want to use it in your own save. But before I do that, I'll just quickly run through how it works. So this is my 2029 Cubs save for OOTP. And what I would do is I would go to Game Settings, Database, and then I'd go over here and click Export Data to CSV files. Once that data is exported, I then go over to the code. Here's the code. And then I would run this command, which runs this script, which I'll explain later in the video. And that will generate 3 HTML files, which it describes here. One called hitters, one called pictures, and one called hit prospects. You can then bring those up in the browser, and those are the projections. So there's a page for the pitcher projections, the hitter projections, and then for hitter prospects. The pitching page covers the guys that are playing in the league and the pitching prospects. So quickly going column by column, you've got the guys who are in the minor leagues have got a 1, 0 if they're not. The innings pitched of all the pitchers in the league, a wins above replacement projection as both starting and relief pitchers. The way I've got it set up is if a pitcher's got 3 pitchers with ratings 45 or above and stamina of more than 40, they're a starter. Then if they've got 2 pitchers of rating more than 45, then disregarding stamina, they're a reliever. You can change those thresholds in the code. Then you've got a weighted on base average projection for every pitcher. This is what's used to generate the WAR projections. Come on to the numbers in a minute. You get the splits right and left-handed, and the overall is calculated 70% right plus 30% left. And then you've got the same things again based on potential. Now onto the hitters one, pretty similar. Over here you've got a by position projection of wins above replacement. Whatever the best position is, the wins above replacement is over here again. The potential one is here. The weighted on base average is here with the right and left split and the potential again. And then you've got a field column here, which is just telling you, according to a bunch of thresholds, again, you can change whether a player can field a position. So for example, this player can field second and third base on the projections. This player can field right field and left field. The prospects page then does the same thing, but it just sets out all of the position by position projections for potentially. So if you click, for example, third base here, and you've got the projected wins above replacement. And then this field column, what you could consider doing is adding a condition up here and saying it contains third base, for example. So according to this projection system, these are all the players that have got the bars for a third baseman, and then this is their projection based on their potential ratings in game of what they could be as a third baseman in terms of wins above replacement. If I go back to the hitters one, you can get the same idea around using this condition thing to do all sorts of things in the game. So for example, my team is the Cubs. So if I change organization to equal the Cubs and then ask it for the best weighted on base average against left-handers, then this is going to give me a good shout for what my lineup ought to be against left-handers, and then this against right-handers, for example. Or in the pitching one, for example, I could ask it, who's the best pitcher according to the projections, who's pitching in the minor leagues? And you get various guys here. Here's a guy that's already pitched 23 innings in the majors, so he's probably on a rehab assignment. But here, for example, is a guy who's age 28. He's got a better than league average. I think league average for, or at least it's set to be about 320 on WOBA, so he's a little bit better. Yes, he's a bit splitty, but the split favours right-handedness, which against right-handers, which is, I would say, better. And sure enough, when you look at this player in game, he looks fairly decent. Looking at the ratings, you can see better against right-handers than left. And then looking at the stats, he's never been given a chance to pitch in the major leagues. Not really obvious why. His AAA record is pretty good. FIP minus are better than 100. You can see the split. That's where he is against lefties. Against AAA righties, okay, it's only 17 innings, but he's plainly pretty dominant, and he could probably pitch reasonably well in the major leagues. So you can use a projection system like this to find guys like this in game. These projections are now a bit similar to the Football Manager one that I've built, which is on screen here, which has proven pretty popular and now has thousands of regular users. It's the same idea. I've built this for me to use, but I've made it broadly available. It's free for anyone to use. I built it for fun, to increase the immersion I get from the game, to make it feel like I'm in a data-driven, quantitative front office of a real sports team, which for me is the point of playing these games. Happy to release it here in case it's useful for others. So what I'm going to do now is a detailed step-by-step instruction on how to get this thing set up. So the first thing you need to do is, in your Out of the Park game, you need to export the right data so that the code can read it. So the first thing is, I do think you will need to be able to use Out of the Park 26, latest version. It might work on 25, I don't know. I'm almost certainly won't work on the previous versions because the data structure of the game has changed a bit. First thing is in the settings here, the ratings scales on the left-hand side need to look like this. So you need to have, in particular, the overall potential ratings 20 to 80 in increments of 5. That's what the code is expecting. If you have 1 to 100, for example, and you don't have the increments of 5, it just isn't going to work. The way that I've built all the testing that underlies the projections is 20 to 80 in increments of 5. So you need to have it like that. Once you've got that, you then go to database here, and then database tools. The first thing you need to do is you need to configure data export to CSV files, which is this thing here. And it needs to look exactly the same as this screen here. So if you just copy this, and as I scroll down slowly here, hopefully you can see that fairly clearly on the video. And you just need to copy that, same ticks as I've got. I'll just go back up to the top. Just needs to be the same. So once you've done that, click save here. Then what you'll find is you can click export data to CSV files. Now I'm going to click this just so you get a sense for how long it takes when I click it. It's not immediate. It takes a little while. Well, time it maybe takes 20 seconds or something. Of course, it'll be different for you depending on your computer, its speed, your save, its level of detail, how many leagues you've got loaded, all that kind of stuff. But this is mine, and it probably takes, I don't know, 20 seconds or something. So what the game is doing now is it is generating a bunch of files with the core data about the players, the coaches in your game. And it will do that. You can see there's millions of lines of information. But this is the thing that the code in a minute is going to go in and read. So that's done. Now what we can do, we've got here open data import export folder. So this is just a thing telling you at the bottom here. And in Windows, it'll look different. It'll be something that has your hard disk. It'll say like C:// and a load of other stuff. It's just the path to get to the folder that's got these CSVs in. And these are the ones that have just been created. It was created just now, and they're quite big files. But that is all done. So we'll just leave that window there because we'll come back to need this path in a minute. Okay, so the next step is we need to get the code that I've got on the screen here into your computer, because the code needs to read all that data we've just exported from the game, perform a bunch of calculations, and then export the websites with the projections, which is the thing we're trying to get to. So to do this, we need to do two things. The first thing is we need to download the actual code. And the second thing is we need to create all this stuff on the screen that actually runs code. So coding people would call this creating the environment that runs the code. So to create the environment, there are 4 things we're going to need. We're going to need VS Code, which is this thing that's in this window here. It's this piece of software. VS Code is the name of the thing that I'm using here to run the code. That's 1. 2 is Python. Python is the programming language that we're using, that this is all built in. So 2 is Python. 3 is we can use something called Anaconda, which is something that installs a few things that this code needs called packages. There are other ways you could do this, but Anaconda I think is a relatively simple one for a new user. And then the 4th thing we need to use is something called Git, G-I-T, because that's how we're going to get the code into this, download it into this in a minute. Now the problem here in doing a setup video is that everyone's computer is going to be a little bit different. So I use a Mac computer, but I do sometimes use a Windows computer. It's most likely that people watching this are going to be using a Windows computer. If you've never run code before and getting VS Code, Anaconda and Python set up is unfamiliar to you, this video is very helpful step by step on that, and I'll put the link in the description. I suggest you do that, particularly if you're on a Windows computer. It'll just be the quickest and easiest way to get where you need to get to. Don't be afraid to use ChatGPT as well to handhold you through the specifics of your setup. This step 1 here, installing the various things, should be covered in the other video, although I think you might need to install Git separately. Then we get to this step. So if you've got VS Code and Python set up, we now need to pull down the actual code from something called GitHub. This is GitHub, and again, link in the description. Here we are. I call it Pistachio. This system is just to give it a name. This is all the various bits of code you need. And then down here is a README written by me, which goes into detail on how you run this code and how it all sets up. This command here is how you tell the computer to use Git to download from GitHub the code. Once you've done all that, you should end up with something fairly similar to what I've got on the screen here in Visual Studio Code. You've got a folder on your computer that is called Pistachio. It's got a script in it called main.py. .py tells the computer that is a Python script. It's written in Python programming language. And then this is main.py. And what it's doing is referring to a bunch of other scripts. So you can see, for example, it's referring to a script called reader. That's this one. It's referring to a script called metrics pitching. That's this one. Metrics hitting. That's this one. Metrics war. That's this one, and so on. And then it basically is telling the computer what it wants it to do. And actually, the idea is it's written in a way that is relatively clear and easy to understand. It wants the computer to load players in from out of the park baseball, all those CSV files we started from. It wants to give some come up with some stats for the player's pitching career, how many innings the player's pitched this season, hitting career, how many plate appearances the player has had this season. Add in all the ratings from your scout, we'll come on to talk about in a minute. Count how many good pitches a pitcher's got. Can they field various positions? Has a player been flagged? So you can put in here the ID numbers of various players. Those ID numbers will come up as a flag in the outputs. You can use that, for example, for draftees, people in the Rule 5 draft, or anyone on a shortlist. Then calculate metrics. Tell us about the guys at pitchers, potential metrics, hitter, potential hitter, and then fielder. And then off the base of all that, calculate wins above replacement, and then export a load of pages. So that's what the code's doing. And each and all of these things, you can sort of look up here to see where those various bits of code are. So for example, the calculate fielding metrics thing that's down here is in this thing called metrics fielding. And you could go into metric fielding, have a look at how it does it if you're interested to do that. And in particular, we need to do some configuration of all of this before you use it anyway. So once you've got to this stage, before we can just run the code, the way you would run the code is this command down here, python main.py. But you're not quite ready to do that yet because you need to go into this configuration one here and configure a few things up here. So let me just explain these. The first one is where it says file path, and then we've got a path. Now earlier in this video, we looked at the folder that contained all the CSV files that's been exported by the game. We came back and we said there's a little path here. So you need this path. So in Mac, what you do is you click the right click and then you hold in the option button. And when you hold in option, this thing called copy CSV as path name comes up. You can copy that and you can paste it in here between these quote marks. If you're on Windows, you'd do the same. It would probably say C:/ whatever, or maybe D if your hard drive is D, not C, or whatever. So that's that's the first thing. You're telling the code where to find the CSVs. The second thing is you're telling the code where to output the HTML files at the end to. Here we've got one in Pistachio folder called /outputs. It just goes in here, so you need to tell it that. And you also need to tell it where this Pistachio folder is on your computer. That's where mine is. Yours will be obviously somewhere else. So that's the first thing you need to do. The next thing you need to do is you need to tell the code the ID of your scout in the game. This, in my case, is 3332, but yours is going to be different. Again, if we go into this CSV thing and go into the coaches one, which will have been exported, you can open that in Excel and you can look up the coach ID. Here it is. So you look up the name of your scouting director in game, and then you find them using this last name column, and then whoever it is, you just get this number and you put it into the game. Sorry, not into the game, into the code. Then the team managed. I'm the Cubs at the moment. We've got this lookup table here of, in the CSVs, you get numbers between 0 and 30 for the organization. 0 is a free agent, and then 1 to 30 is the 30 clubs in Major League Baseball. If your league is different to the Major League Baseball default setup in the game, all you need to do is go into this code and just carefully amend it to reflect whatever's in your game. If you open this one, players.csv, and then you can see a column called organization in here, which you can use to figure out which players are in which organization, and you can sort of map back if you need to, if yours is different. Next thing, just rolling down this config.py, if this is what we've got as the defaults for if a player can field a position. So for example, the code thinks that a player can field center field if their range is 70 and their outfield range is 70 and outfield arm is 50. If you think it should be something different, go ahead and type it in and it will be whatever you think it should be. Pitchers, I think a pitcher is a starter if they've got 3 pitches better than 45. If you feel differently, you can change that as well. Whatever you change, just remember to save it in this config.py. Literally just save the file in VS Code. And then once you've done that, your code should be good to go. And then when you want to run it, like I say, you just have to type in at the bottom here. This is a terminal. So in VS Code, you need to open the terminal. And once you've done so, if you just type in Python and then main.py, that actually runs all this. So this is going to take a little while. I'll run it now live. And what the computer is now doing is it's going off to read all those CSV files that we exported from the game. It's doing all the various calculations that we set out here with all the various constants. And in a minute, I'm going to go into detail. This could be quite a long video on the projections and exactly how the projections work and exactly what the calculations are that this thing is doing. But for now, let's just get to the point where we've run the code and produced our own HTML files and the thing actually works. And then I'll go into detail on what it actually is. So it's just the terminal is just exporting a load of stuff just to kind of give you a bit of running commentary on the fact that it's actually working, and it is working and it has worked. So now we've got 3 exported HTML. As you can see, this HTML export has occurred. It's in the folder outputs, and you specified outputs here. You told the computer where to put things, and now it's just telling you, yep, okay, I've done it. I've exported one called hitters into that folder, hitters.html, and you can literally copy that, open a browser window and paste it in, and then it'll take a little while to render in the browser and we should be done. So that's basically how it works. You set up out of the part to run 28 in increments of 5. You set it up to do CSV exports with the right files. You set up the code by having VS Code, Python, Anaconda and Git, so it's all set up. You load the code in, you run the code, you've set up the config.py, you run the code, and then it works. And there's a lot to do there, but once you've actually got it up and running and it works, and obviously if you're struggling, if you put stuff in the comments, I'll see if I can help, and I'm sure other people will help as well. But I think people are getting it up and running now. A few people I've showed this to have managed to get it working. It all works fine. Once you've got it up and running for the first time, it then becomes no more complex in the game in terms of the flow of how you play the game. You simply go to database, you go to CSV, output it all, go into the code. In this part of the code, when you're in the terminal, just press the up button. It gives you the most recent command. You just run it again, bash, and it will just come out. And then once it's done that, you would go in here and just refresh this website and it's done. So say you're in the draft, for example, you do it, just before the first round, you do it for your first round pick, you might do it again for your second round pick. I should actually just show that part. So if you're in the flagged here, what you can do, if I just delete it, that's going to flag nobody. I had a load of guys called flag, and if I go to data, I go to flag equals flagged, what it'll do is it'll just keep these guys. So if you've done a draft, for example, you can flag all the guys who are available to you in the draft. Once you get to the next round, you can do exactly the same thing again. It will just remove the guys that aren't available in the draft anymore, for example. So here what I've said is to the game, give me all the players that are captain personality, overall rating more than 50, and you get these players. In fact, you don't, because that says all batters, all players. So this is now all the players that come up. And what I've just done simply here is in the view screen, I've created a view called just IDs. And so what I did there, I went to customize and I literally just put ID and nothing else. This is now the IDs for those players. I can go to report here and write report to disk. It's going to give me this website. I can then just copy like that. I can paste into flagged.txt like this. I can save. I can run Python main.py. The system's going to go and do its thing. And now this is the updated hitters page. And I can say, okay, cool, give me the players that are flagged, where flag equals flag. And this is the guys that appeared. And I can now say, okay, cool, give me the best weight on base average amongst these captains. Give me the best right-handed hitter. Give me the best left-handed hitter. All right, projections. So I'll put again in the description, but it's also on this GitHub thing, a link to this Google sheet here, which contains the detail of the projections. So this goes into quite a lot of detail. I'll jump to the most important bit, but then I will go through this in close detail because I think it's interesting, and I'm very interested again in the comments, in anyone's views on ways that I can obviously improve this. I'll start with this tab called Runs Tables because this basically cuts to the chase of the important stuff. What we've got here is 3 tables at the top. The left-hand one is about fielding. This one's about hitting in the top right, and this one at the bottom right of the part I've selected here is about pitching. We'll start with these ones because they're simpler. For a pitcher, what I've simply done is run lots and lots and lots of simulations in the game. And I've used this thing which you can only use in commissioner mode called the simulation module for this. I've created a test league where everybody's rated 50 for everything. And then I've varied one at a time all the ratings 50 to 55, then 50 to 60, then 50 to 65, and so on, to see what it did, and then I've worked from there. So if you look at this picture one, for example, with everyone at 50-50, there's no change. But if I then change control from 50 to 45, then the pitcher gives up across 162 games 3.6 more runs, and that's across 100,000 simulations. Then 50 goes to 40, it gives up 9 more runs per 162 games. Control 35, 12 more runs, and so on. And I've done that for every rating for the pitcher, so you can see, for example, that home runs allowed and stuff seem to make the biggest difference. And then I've done it for hitters. Again, all the ratings starting from a 50 base. And then I have done it for fielders in the same way, which is down here. But in order to make these make a bit more sense, I've had to smooth it a bit because some of the ratings tests were a little bit surprising. But just going through, you can look in really close detail at what I've done here. But just to sort of make the numbers make enough sense, they go in sensible linear directions. Then I've said 50 rated isn't really a league average or replacement level player as a fielder. It varies by position. So in order to make this make sense when going on to calculate wins above replacement, I've tried to rebase to a replacement level of 60 for catcher framing, or 55 for right field outfield error, or 45 for first base infield range, and so on. But the idea is that overall these tables are a decent summary of what the projections are doing. There's a bit more detail in this for hitting and pitching, which I'll go into in a minute. Then on this tab, there's a bunch of known flaws. I won't run through this in close detail, but the main thing to say is if I was doing this again, I probably wouldn't run it all 50 rated for the fielding. Hitting and pitching, I think it's fine. For the fielding, I think you're probably better off coming up with a more representative major league environment than 50 rated everything. It means, for example, you've got a rubbish shortstop out there in every simulation. But I think this is more than good enough, and I've been using this in single player and it's been fine. Is it the most optimized out of the park projections imaginable? No. Is it more than good enough for the typical single player like my FM one is? I think at this stage, yes, and I've been really enjoying using this stuff. Right, into the detail of how I built the projections. So I mentioned everything was 50 rated, and then I wanted to see how much things would vary. The first thing I did was I created 2 identical teams, and then I ran loads and loads of seasons to figure out how much simulation needed to be done for it to make sense. And this tab called stabilization goes into that. If you read Fangraphs, there's a lot of stuff in there about how large a sample you need for various statistics to stabilize in baseball, and this is a similar kind of idea, although much simpler. I wanted to figure out how many simulations do you need to stabilize things like win percentage for a team, run percentage for a team, a pitching statistic for an individual pitcher in this case, whip, and then OPS for an individual hitter. And I think the answer as you look at this is you need to do quite a lot of simulation for the individual statistics to stabilize. And I ended up settling on 100,000 games, which is an awful lot. It takes 3 minutes in real time to simulate 100,000 games, so it meant running all these simulations took a decent amount of time, but it was what needed to be done for the individual statistics to stabilize. The team one stabilize sooner. 10,000 games looked pretty fine for win percentage, and then for run percentage, which stabilizes sooner than win percentage, that's absolutely fine. And then as a byproduct of this analysis, you can see what a 162 game season does, and you can see just how much randomness is in a 162 game season. and precisely what kind of amount of randomness. And you can see on the right hand side here in this histogram, you've got two teams which are identical. And so in 162 games, the first team should win 81 games and the second team should win 81 games. If 162 games was enough games to identify team strength in baseball, but it isn't. You can begin to see what the shape of this histogram would be if I'd run enough simulations. It has tails at both ends. The tails go to something like high 60s and mid 90s. If you do it in terms of percentiles, the quarters in that percentile distribution would be something like 75 to 85. Or if you do it by a standard deviation, you're seeing something like 7 wins plus or minus on 81 of just pure luck. But the amount of pure luck can be even more than 7 wins. It can be quite a big number. So if you want to become a 90-win team and out of the park so that you can get into the playoffs every year, I think you need to shoot for trying to be a 97-win team to try and make sure that you don't get hobbled by luck too much. And for me, what I think this is telling me is if I start the season on opening day with a team I like, I should try to at least give them through to the draft and probably to the trade deadline before I make any significant changes. All right, into the projections. We'll do hitting first. So again, what I've done is loads of simulations with everyone's hitting ability at 50 and everyone's pitching ability at 50. And then I've used this simulation module to establish these things over here, which are the components of weighted on base average. So the percentage home runs, percentage strikeouts, and so on and so on and so on. I've had to use a slightly blurry estimation of plate appearances for this because the simulation module only gives you at-bats, but it seems to work all right. Then using these various calculations, what I've then done is calculated a estimated weighted on base average. In order to do that, I've used this bunch of constants which come from the sabermetrician Tom Tango and come from real life baseball. Mine come from my copy of the book, but if you haven't got a copy of the book, they also are on this website here. And they basically mean what is the value in runs of scoring a home run. It isn't 1 run, there might be people on base, so on average it's 1.95 and so on and so on. Once I've done all that, I can then isolate the value of the ratings in terms of the components of weight on base average. So for example, if a player's got BABIP of 55 and not 50, as we go over to the right hand side, compared to a baseline guy, they're more likely to get singles, slightly more likely to get doubles. So these numbers up here are the baseline for the all 50 hitter. And so a all 50 hitter is going to get something like 3% of their plate appearances, they're going to score a home run, whereas the power 80 guy is going to have something like 8 or 9 out of 100 plate appearances, they're going to score a home run, which obviously makes a massive difference. If you just want to use this spreadsheet to estimate one player, you can do that by just going in here. They're all set to 50 at the minute, but if you want to put your BABIP to 55 or your power to 75 or whatever, it just takes that all 50 guy here and then adds whatever the correct estimates are to reflect the ratings, and then it leaves you with a weighted on base average number. If I do that more slowly, you'll see the all 50 guys at 320, but if I do BABIP 55, no power 75, it goes to 403. Now the reason why that's important is because what this model then goes on to do is it uses all this previous data to establish a line between WOBA, weight on base average, and then runs per 162. And as you can see, it's a pretty tight relationship in the test data with an R squared of 0.99. This enables us to build whatever hitters we've come up with in terms of a runs per 162 number, and that's what goes forward into the projections. Moving on to pitching, it's exactly the same idea. You've got control, you've got BABIP. This time it's home runs allowed, and it's exactly the same idea. So compared to a pitcher with 50 home runs allowed, what happens is you've got 80. Well, we can find out. We go over here. This is all the data from the testing. And if we compare against the baseline guy, the 80 rated pitcher reduces home runs allowed by 1.7%, which shows you the value of the hitter's high rating is probably more important than the value of the pitcher's high rating. Although I don't know that for sure. That's a whole different conversation. For the purposes of this, simply these are the numbers that go down into a similar calculation down here. And I'll delete all these so that we've got an all 50 pitcher. This is a WOBA projection of 0.318. And then if I put in the home run guy at 80, what we're going to see is that 0.318 goes down to 0.290, which is worth, on these numbers, 18 runs per 162. And again, you can see the trend line with the high R squared to sort of give a little bit of confidence that this projection makes some amount of sense. One other thing when you compare this to the previous projections I was using, which I did post here on YouTube, but I would recommend updating to this because I think this is substantially better, is that I'm not trying to isolate the ground ball percentage anymore. On further testing, I think if you just look at the home run allowed number, that makes much more difference than the ground ball pit. And I think one is subsumed within the other. It gets a bit complicated in the editor. I don't particularly feel as if I 100% understand what's going on, but put simply, if you calculate like this, I'm fairly sure you get outcomes that you can backtest and make more than enough sense. Again, are they the most optimized calculations imaginable? No, there's a bunch of known flaws written here. Are they more than good enough for the typical single player of this game? I think so, yes. And if you don't agree, I'd love to hear substantive comments in the comments here. That would be really helpful. Right, defense, last detailed dive onto the projections, and it's exactly the same logic. 50 rated everything fielder versus a guy with 55 catch framing, 65 catch framing, and so on. The only thing here, it's a lot simpler. I just worked out what the runs per 162 impact of that is. So if you've got a guy with 75 catcher framing as opposed to 50, according to these test numbers, it makes 12 runs of difference across the season, and so on and so on and so on. There's a few slightly surprising outcomes in all of this compared to the conventional wisdom of Out of the Park. Again, it's all summarized here. I think for the time being, I'd simply say these seem to give a sensible reflection of what's going on out of the game engine. And certainly when I switch to these as the projections I'm using to underpin my playing of the game, I haven't yet seen anything too weird happen. So even though, for example, the way second baseman infield range looks a bit weird, if you've got more than 55, these numbers seem to indicate it makes next to no difference. That's a real surprise to me, but if you can find a 55 infield range rated guy who can really hit on your team and they've got a decent arm, I've put one in my team, it seems to work. And these are numbers which are deliberately intended to be equivalent across fielding, hitting, and pitching. And the idea is that, like WAR does in real baseball, it attempts to try to capture the relative value of all the various positions and all the relative skills. Now, does this do it perfectly? I'm not saying that it does it perfectly, but it certainly is trying to do that with rigor. And that's even if it leaves somewhat surprising results. So if I open my Chicago Cubs pitching staff here and I sort it by wins above replacement, it says that my best starting pitchers, and some of these guys are good starting pitchers in game, have only got 0.9 as the starting pitcher WAR projection. That's a good pitcher, and it's tempting for me to just multiply these numbers by some factor to make these projections higher. Certainly in the game, these players are getting higher WAR numbers. But I haven't done that because I think it's probably best leaving them as they are. And the main thing anyway is to be able to use these numbers to rank players between themselves within a position group. The comparing across position groups and across pitching and hitting is, I think, it might be a nice feature. It's nice to have, but I don't think it's the main feature of this. But I would say if you believe these numbers, and to a fairly decent extent I do, I think what it is trying to tell you is the hitting side of position players is the most valuable thing in the game. From fielding, you just need to avoid the mistake of having players in certain positions who are way below how good they need to be, most obviously at centre fielder, second base and shortstop, where you just need to get players of the right quality level. And then once you do that, it's just about optimizing for as much run creation and runs saved as possible, which is the whole point of using a projection engine to help you look at all the players quickly and figure out which players do that the best. All right, I think I'm going to leave it there for this video. This is quite a techie video, I recognize. I've tried to make this as user-friendly as possible, and I hope even if you don't go into the coding and all the rest of it that I've shown here, there's enough stuff here to just help you think about how you play Out of the Park. Anyway, if you're watching this and you're a code developer and you want to pick up this code and change it in whatever way you see fit, go ahead, be my guest. That would be cool. If somebody wants to build a web-based, super user-friendly front end for this, in the same way that somebody did for my FM scoring system, even better, would be fantastic. And I imagine there'll be a few people who play OOTP who would love to try to use something like that. Otherwise, if you do this, I hope you get as much enjoyment out of it as I have This has absolutely transformed my playing OOTP this year. I'm having an absolute blast doing it. Thank you for watching this video, and I shall see you in the next one.